We're going to talk about convergent geometric series, and we're going to find out if there's a sum. This is lesson 14.4a. We're now up to 11 previous videos for chapter 14. If you become lost or confused, my advice is to go back, check the description, and watch the ones that you were missing to fill in any holes in what you know. For an infinite geometric series, as n gets larger and larger, the sum of the first n terms gets larger and larger. But for geometric sequences with fractional ratios, numbers between 1 and -1, the numbers get smaller and smaller. And the sums of the terms in these sequences never exceed set constant values. So if we have a half plus a fourth plus an eighth plus a 16th plus a 32nd, and the nth term would be the quotient of 1 and 2 to the nth power, see that? This is what I'm talking about, because it's going to be fractional ratios. If the ratio is larger than 1, the sum gets larger and larger, and we get no final answer. If the ratio is negative, and between 0 and -1, the sum is a single constant value. If the ratio is smaller than -1, like -2, -3, and so on, we won't get a final answer either, okay? So here we have our half plus fourth plus eighth plus 16th and so on. And the first n terms for some values of n would be, a sub 1 would be half, right? Then the sum of a sub 1 and a sub 2 would be 3/4. The sum of the first three would be 7/8. The sum of the four would be 15/16. See how it's slowly getting more and more towards a 1? And see how the numerator is 1 less than the denominator? 1 is just 1 less than 2. 3 is just 1 less than 4. 7 is just 1 less than 8. 15 is just 1 less than 16. Each denominator is in the form 2 to the nth. And each numerator appears to be 1 less than its denominator. There's a pattern form that can be described as this formula. We've got s sub n is equal to the quotient of 2 to the nth minus 1 and 2 to the n. As n gets very large, s sub n gets very close to 1. We say s sub n approaches a limit of 1. We define the sum of the infinite series, this series, because it goes on infinitely, right? We see our ellipses, to be 1. Okay? I'm going to skip over here to explain this to you, all right? The sum of this infinite series of fractions is equal to 1 whole square. So let's take a look at this. We have 1 whole square. This is half. If we add this half to this fourth, to this eighth, to this 16th, to this 32nd, to this 64th, to this 1/128th, to this 1/256th, to this 1/512, and it gets smaller and smaller and smaller. If my marker was small enough, I could have kept going, couldn't I? When we add all of these together infinitely, half plus fourth plus eighth plus 16th, we end up with 1 whole square. See? We get a 1. All right? Does that make sense? So, if in an infinite series, s sub n approaches some limit as n becomes very large, that limit is defined to be the sum of the series. If an infinite series has a sum, then it converges or is convergent. So to converge means to come from different directions and meet, or to have a finite sum, to have a sequence of partial sums that converges. Convergent means tending to come together or merge, okay? Some infinite series converge and some don't. So here's a theorem for you. An infinite geometric series is convergent and thus has a sum if and only if the absolute value of the common ratio is less than 1. Okay? Here we've got some alternate signs. To find if this series has a sum, we find r. Just find r. You know how to do that, right? Half divided by 1. We do a sub 2 divided by a sub 1. We get a -half. A sub 3 divided by a sub 2. We get a -half. So we know r is a -half. the absolute value of r is less than 1. Negative half is less than 1, isn't it? So this series has a sum. Okay? Let's see if we can determine if the geometric series has sums. We have 1 plus 5 plus 25 plus 125 plus and so on. Got our ellipses. We find r. 5 divided by 1 is 5. 25 divided by 5 is 5. R equals 5. The absolute value of r is greater than 1, so this series does not have a sum. It has to be less than 1, doesn't it? How about this one? We've got 1 plus negative 1 plus 1 plus negative 1. Well, negative 1 divided by 1 is a negative 1. And 1 divided by negative 1 is a negative 1. So r is a negative 1. And the absolute value of r is 1. Now, this series does not have a sum. The absolute value of r must be less than 1. Can't be equal to it. So there's no sum. Okay? Take a look at this one. We have 1 plus a third plus a ninth plus a 27th, etc. We find r, 1/3, divided by 1 is 1/3. 1/9 divided by 1/3 is 1/3. So r is 1/3. The absolute value of r is less than 1, so this series has a sum. Okay? It's pretty easy, really. If you know how to find r, it's pretty easy to do this and just do the quick division to find r and see if it's less than 1, and you'll know it has a sum. Okay? Our next lesson is finding sums of infinite geometric series. It's going to be 14.4b. This entire 14.4 videos that I'm making, there's a few of them, are all about infinite geometric series, okay? So, I hope you're doing well. I hope this is helping you. If it does, hit the like button. Let me know, okay? And don't forget, you can always direct message me on Twitter if you have questions, all right? I'll see you next time. Bye.